This video will be about proving triangles similar. So when you have two triangles that are similar, that means they are two triangles with the same shape but different sizes. We take one of them and make them bigger. Let's call this first triangle ABC, the second triangle DEF. So if these triangles are going to be similar, we need some pieces of information. There's three ways we can prove triangles similar. AA, which stands for angle, angle, SAS, which stands for side, angle, side, and SSS, that stands for side, side, side. If you have two angles that match, with our current triangles, they both have right angles, but let's say we've marked a second angle, we could say these two triangles are similar by angle, angle. They have two matching angles. That makes these similar. We know they're the same shape, just different sizes. We could also do a triangle similarity statement. The first triangle, we usually just pick whatever order we want. The second triangle, we would have to go in the same order. Angle A had the one red mark, so angle D has to go with angle A. So D would go first. Angle B was 90 degrees, so we have to pick the 90-degree angle on our second triangle. And then F comes last. So triangle ABC is similar to, that's what this little squiggly line means, is similar to triangle DEF. It's nice enough and easy enough when they're separated, but sometimes they're going to give you triangles that are not separated but really are two triangles. So let's say this is our triangle. Now there's actually two triangles here. The big outer triangle, triangle ADC, and the small inner triangle, triangle AEB. So we would want to know, are these similar or not? In order to do that, we have to decide using proportions. We need to set up a ratio and see if the ratio of the sides are the same. And actually, I need to label one last set of sides. Okay. So there we go. So to check our proportions and our ratios, we take our corresponding sides and set them up as a fraction. 3 is the bottom of the purple triangle, and 6 is the bottom of the blue triangle, so those would go together. 4 is the left side of the purple triangle, and the blue triangle, the left side, consists of both of these numbers added together. The 4 is only talking about the top half, and the other 4 is only talking about the bottom half. So we have to add them together to say, okay, from A all the way to D, that's 8. And the last one, 5, is the top right of the purple triangle. We need the right side of the blue triangle. Again, we have to add, which gives us 10. So we're trying to prove this, that these are similar by side, 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 because we have all the sides corresponding to each other. So we have to reduce these fractions to see if they match or not. 3 divided by 6, well, both of those numbers would divide by 3, which means we have 1 over 2. 4 over 8, both of those would divide by 4, which means we have 1 over 2 again. So we're good so far because they match. Let's check the last one. 5 over 10, both of those divide by 5, which gives us 1 over 2. That also checks out. So these are similar by side, angle, or side, side, side. And we could name our triangle statement. So AEB on the purple triangle would be similar to ADC. We have to go in the same order. Now if I changed one of these numbers even just a little bit, if I put a 6 here instead of a 5, when we got over here to the 5 over 10, that would really be 5 over 11, and this wouldn't match anymore, and we could not say that they're similar. They would all the proportions have to match in order to say that it's similar. So one thing they can do with one like this is not actually label anything, but just say these bottom lines are parallel. Again, we still have two triangles here. We have the outer blue triangle and the small inner green triangle. And I can actually prove these are similar even though nothing has been labeled, except the fact that these bottom lines are parallel. Because they share the same angle here at the top, angle N is the same for the green triangle and the blue triangle because they meet at the same spot. And because we have parallel lines, we know when a parallel line is cut by a transversal that the corresponding angles match each other. So we already know that these two triangles are similar because we have two angles matching each other, angle N and angle P in the green triangle, and angle N and angle R in the blue triangle. So these triangles are similar by the angle-angle postulate. And they didn't even have to label anything for us to prove that they were similar. So the last thing they can do is they can give us one where we have to set up a proportion and solve. They can say, okay, these triangles are similar, set up a proportion and solve that proportion. So looking at our triangles, again, there's some things not labeled here. We know angles across from each other are the same. Those vertical angles match. And we know that when a parallel line is cut by a transversal, that those angles match as well. So these are similar by angle-angle, but we can use that to solve for x. We're going to set up a proportion with fractions on either side. So I'm going to take one triangle and work with it first. So this left triangle that's just a little bit bigger, we have a 5 and a 4. I'm going to make that the left side fraction. The right triangle, when we set up our proportion, we have to put the corresponding pieces in the same order. 5 was touching that angle from the middle, and then also had one side that we didn't label at all, or one angle we didn't label. So we need to choose either 3 or x that is touching the angle in the middle, but then is also touching the angle that we haven't labeled. So the 5 must correspond with the x. That means the 4 corresponds with the 3. Once you've set up your proportion, you just cross multiply and solve. 3 times 5 is 15. 4 times x is 4x. If we divide both sides by 4, 15 divided by 4 is 3.75. And you could write it as a decimal, or they may ask you to write it as a fraction, in which case we would have left our answer as 15 over 4. So we can also set up our proportions to solve for values of x, just keeping in mind that we have to go set up our proportions in the same order. So that concludes our discussion on proving triangles similar.